right. Welcome back. Let's talk about electric force. So in the last video I mentioned, hey, opposites attract and like repels like. Let's start the new stuff. So just about everything you're used to with charge has charge because it either is an electron or a proton, or it has more electrons than protons or more protons than electrons. So just about all charge you know of is due to protons and electrons. They're not the only things with charge in the world, but they are all very much the most common. You're not going to run into other things at all in Physics 12, and unless you do a career in physics, probably not with other things, except for muons, which are responsible for a significant dose of your daily radiation, but not something. They're quark-antiquark pairs caused by charged particles from the sun hitting our upper atmosphere. Great example of relativity. Anyway, sorry, shouldn't make this too long. So, charge is measured in coulombs. And 1 coulomb of charge is equal to 6.24 times 10 to the 18 protons if you're talking a positive coulomb, or if we're talking a negative coulomb of charge, it's this many extra electrons. It's a stupidly huge number, but one that works on the macroscopic scale for big things like us. Though it's still actually a lot of charge even from our perspective. The elementary charge is kind of the reverse of that. So notice this is kind of protons or electrons per coulomb of charge. Whereas this right here, this is called the elementary charge. This is the coulombs per proton or electron. So if you do 1 divided by this guy, you get that guy, because it's kind of the flipped version, coulombs per proton or protons per coulomb. 1 divided by, or to the power of -1, flips one of these guys to the other. You will probably end up at some point converting between protons and coulombs, or coulombs and protons, or electrons to coulombs, or coulombs to electrons. So know these guys. Keep in mind that this is in your data pages, this elementary charge thing, this number right here under elementary charge. This guy is not. This is not in your data pages, but it is just this guy to the -1, or 1 divided by this guy. So be ready to switch it into either form. You might want to write this down now, or just remember that it is the reverse of this. Just know what elementary charge is, very important. By the way, a proton has just as much positive charge as an electron has negative charge. So our big new formula right now, I've written the gravitation formula just for comparison. In gravity, we had the force of gravity was equal to some constant to make the units work, times the mass charge of object 1 times the mass charge of object 2 divided by their distances squared. For electric force, which is what we're talking about today, that's going to equal some fundamental constant, Coulomb's constant. It's a K, also in your data pages. It's also really easy to remember. It's 9 times 10 to the power of 9, 9e9. So this is always, no matter what, everywhere in the universe, 9 times 10 to the 9 Newton meter squared per coulomb squared. So be able to use this guy, just a little constant in your data pages. And then multiply that by the charge of thing 1 in coulombs. So if it gives it to you in microcoulombs, if you see that thing if you see this symbol, that means 10 to the -6. So you got to include that if you see microcoulombs. That would be 10 to the -6 coulombs. So be on the lookout for this micro symbol if you're not familiar with it. All right, so multiply charge of object 1 times charge of object 2 divided by distances between their centers of charge, which is usually just their centers, in meters. So make sure you're using the correct units, coulombs. If there's a micro, throw in a 10 to the minus 6 and have the distances between their centers, and you got your constant here. Keep in mind force is a vector, so you will have to add it like a vector. So if one thing is trying to push something to the right and the other is trying to push something down, you'll have to build a little triangle. So something's trying to push something to the right and something's trying to push something down. Your net force will be what you get after you do Pythagoras with the two forces. And you'd find each individual force with this guy right here. Okay. I'd say any questions, but no dice through here. If there are questions, please see me during office hours. And have yourself a great rest of your day.